Excellent. Good afternoon, everyone. My name's Nathan Keller. I'm the moderator for the Innovation Theatre. This is the final session for today, and I'm joined by Rohit Pitale, who's the co-founder and chief growth officer for Unbox Robotics. And Rohit, take it away, and look forward to seeing this contraption.
Thank you, Nathan. Thanks for that. Hi, everyone. Everybody, I hope, is having a good day one at Deliver. Along with me, we have the robot, so just it'll be good to see it in action. We are giving a live demo at our booth also. So here I'm glad to get the stage to talk about the innovation and the differentiation we are bringing in the package sortation automation space. So just a second. Yep. Package sortation hasn't been receiving enough attention into the automation ecosystem yet, as much as, let's say, sortation or picking automation solutions. But it's crucial in many ways. Most essentially, you can see parcel sortation. Every typical parcel in an express supply chain is sorted in multiple places, in the fulfillment center, in the distribution center, in the last mile hubs, also in the returns. So, there's sortation happening multiple times for the same parcel in an express supply chain. And each of them have their own different characteristics, but we are basically able to sort of build a flexible solution which can sort of help in each of these processes. What are the problems we're trying to solve? Essentially, there are multiple touch points, so a typical high throughput, high number of destination solution has multi-tiered sortation processes where you're sorting, you have some sort of a primary sort, then you have a secondary sort, sometimes even a tertiary sort, before you're able to cater to, let's say, thousands of orders, B2C, or even thousands of PUDOs or last mile locations. The second problem is any of these automation solutions require higher installation time, sometimes even as high as 6 to 9 months, and that sort of creates an operational downtime and difficult in scalability. Also, you're talking about when it's conventional automation systems are two-dimensional in nature, so they require much more space and cannot be considered, especially in urban micro-fulfillment centers or last-mile delivery hubs, where real estate is expensive. They're also difficult to scale up and down, like I said, because of civil work happening or fixed infrastructure coming in. Lastly, all of these automation solutions are high on costs and very often prohibitive when you're talking about last mile or fulfillment center expenses. So to solve these problems, basically we built a swarm robotic system. It's called Unbox Sort. I'll just quickly play a video which sort of introduces the system. So at the core of the system is this robot. It's got horizontal as well as vertical movement capabilities. So it moves in three-dimensional space, and extremely high speed, extremely compact, can move in a sort of, generally it's a fleet system moving in a general warehouse floor. It could be also mezzanine, and has multi-level racking on the periphery, which can be designed again with respect to the application. So the whole system is optimized to suit the products as well as the outbound units. As you can see in this video, it's 3-level, probably for a store replenishment or a last mile delivery sortation. Most importantly, the whole system is scalable. As you're growing, as your capacity increases, maybe a festive season coming in, you can quickly add 10%, 20% more robots. And that sort of helps you manage your costs better. So the benefits which this solution offers is quick and easy, very modular setup, requires less than a few weeks on site, and can easily be scaled up overnight depending on the requirements. Because we're using vertical space, we're also saving almost 50 to 70% space compared to other conventional automation systems. In a very dense environment, we are able to sort across thousands of locations, so that helps you reduce the primary as well as secondary sortation requirements, and that increases personnel productivity by almost 3 times. We are scalable, like I said earlier, and this whole thing allows us to offer the whole solution as a service. So robots as a service helps you manage your costs and capital expenses better and see savings from the first month itself. It's reliable and safe. There's no single point of failure as compared to conventional, let's say, conveyor systems, where if the conveyor stops, the whole system stops. Versus in this case, let's say you just need to pull one robot out if it's on maintenance downtime, and the rest of the system continues to operate. The whole system can be generally placed in two applications. It could be parcel sortation or it could be order consolidation, essentially just different ways. In order consolidation, you're handling pre-packed items with respect to order IDs. It could be a store ID or it could be a B2C customer ID. Or post-pack, where you're sorting with respect to carriers, with respect to last mile routes, with respect to different returns categories. How we are adding our value into the typical omni-channel fulfillment center. Let's talk about all the processes, all the way from inbound to deep storage, forward, all the way till outbound. There are multiple key processes happening in an omni-channel fulfillment center. So we are able to, all the green blocks over here are where we are able to add value. Essentially, before packaging, we are able to directly have order consolidation with respect to the order B2C or B2B orders in a very dense environment. And I'll sort of quickly bring you to those solutions later. Carrier-based sortation, where you're basically having multiple carriers outbound and you're sorting with respect to these in pallet boxes. You can have last mile or click and collect or PUDOs or lockers, sorting with respect to each of these entities, or returns. So specifically, if I have to give examples of each of these, let's focus on order consolidation, where typically after you have some sort of a batch picking process, it could be manual, it could be any of the automated systems, like in this case, example could be an auto store system, or a GTP system, or a Locus, or any of these systems. Basically, each of these have pick stations, and each of these pick stations are enabled with put wall locations where 20 or 30 orders are being replenished after the picking happens. Essentially, if we remove the pick station put walls and directly have our system connected to the picking automation system or the manual pick system, you then have the operator access thousands of live orders at the same time instead of just 20 or 30. Now that helps in many ways. And essentially, it's helping you increase the pick density from the same case which is presented by the auto store, for example. Now you're picking, instead of 1 or 2, you're just picking 7 or 8 items and then placing it onto different robots, and the robots then will go and drop it in any of the 1,000 locations. Now that increases the efficiency of the pick system also. Now the operator need not move around at all. He or she is sitting at one place, and the robots are taking care of the order build in a very small space. So this could be a B2C, or as well as you can combine some pallet boxes in the same setup and have your stores replenished in the same system. So you're not having two separate process flows for B2B as well as B2C. It's the same system which is handling both. Talking about some of the installations where we've handled B2C order consolidation. So the videos you see are with a fulfillment center of one of the largest e-commerce fashion giants in India. It's owned by Walmart. And here you can see 6-level dense racking, thousands of these locations in a small compact space of 350 square meters. We have roughly 40 robots handling around 50,000 parcels a day. If you can see the racking in detail, it's multi-level and it's variable size. So the larger orders go at the bottom and the smaller ones go at the top. So essentially that optimization also we can offer to you once we have an understanding of the data. Talking about post-pack process automation, where we are talking about carrier-based sortation. So generally here the throughput is high, but the number of exits are lower because number of carriers are lower. So here, each of these could be a pallet, it could be a roll container. We're looking at somewhere around 3,000 to 5,000 throughput. We're talking about roughly 20 to 30 outbound locations. So here we've done something in a sort of a sports goods brand facility run by DHL, where we are sorting outbound units with respect to different carriers in roll cages, and each of these roll cages is outbound into different trucks. Something like this was installed in less than a week, very quick and easy on a given floor, and easy to integrate, and just, you can see how simple it is. Let's talk about another outbound sortation process where you're handling click and collect, where customers are placing orders online and picking up from a store. Or you have the last mile vans, or you have the poo doors, pick up drop off points, or you have the locker stations. So any of these packed items are being sorted with respect to multiple of these out of home delivery locations or even the home delivery locations. And there in the outbound, we have again a multi-level racking design with one of the largest. This would be a good example of how we are sorting these units into directly into totes, or it would be multi-level chutes, depending on how many units are going in a typical location or the unit. We've done a system installation for this kind of an application in one of the largest fashion retailers in Spain. Here, basically, we are handling packed items, and the same robot is sort of the larger packages. So these robots are handling around 1,200 to 1,500 units per hour and sorting across 200 to 600 different store locations as well as last mile delivery routes in Spain. Now, let's talk about the whole process of outbound and then returns coming back to the same facility. Now, returns typically, if you're talking about fashion, returns need to be categorized into different sizes, large, medium, small, different categories. It could be top wear, bottom wear, accessories, or subcategories depending on the kind of post-processing steps needed. That again can be a mammoth task and a lot more expensive processing, and nobody wants to spend money on returns. So here again, we are able to sort of give a very simplified, compact system which can handle your return sortation directly into these bags. In this particular case, this was a 3PL facility handling returns for different fashion brands and e-commerce players. And roughly, the one which the side video which you're seeing has roughly around 100 to 200 exits in a very small space. 20 robots handling around 2,000 units per hour and sorting directly into these bags. Now, if you notice, these stands over here are basically IoTized, or they have sensors which can help you also acknowledge when the parcels are received by these units, or when a certain unit is full. So the associates need to come and replenish them. All of the real-time visibility goes onto the WMS, so end-to-end orchestration becomes transparent and easy to track. I'd like to talk about one of the case studies. We recently are going live with a customer in Netherlands, in Breda. It's one of the sorting facilities for a large Pudo network delivery sort of brand. They have around 2,500 Pudos where there's a lot of inbound load coming as well as outbound load coming in and going out. And we need to sort these parcels with respect to these large destinations. Now, we're handling large packages. So in a system of this sort, which you can see, basically on the left, you have multi-level chutes in the blue colors. And on the right, you have these roll cages, which are handling larger sort of number of units per batch. So how we did this is in 2 steps. Primary sort, which is happening into roll cages in batches of 1 to 50. And each of these batches then in the second shift goes to the secondary sort, where they get further sorted into 50 multiple basically chutes or bags. So 15 to 50, we are basically handling around 2,500 Pudo locations in a very small space. So this is basically, we're talking about around 2,000 square feet. So here in shift 1, the robots are running in the right-hand side, and in shift 2, they come onto the same robots come into the left-hand side. And this whole thing is because we're able to now give that flexibility of the same robots handling different kind of exits or locations. So in phase 2, we are also planning to have the larger system for smaller packages where 90% of the volume is actually small packages. Again, sorted directly. There won't be any primary or secondary sort, but we're sorting these directly into 2,500 outbound exits. Now that density is something which we are able to offer only because we are going vertical and at a very sort of a high-speed robot manner. So the area is much lesser, because of which the robots need to travel much lesser, and we're able to do this in much lesser number of robots. So cost-effective, space-effective, as well as high speed, because you're not having multiple processes. Yep. These are the different kind of exits we are able to sort of design as per the application. It could be a pallet box. It could be 3-level directly into bags. It could be 6-level, 7-level, depending on what kind of units we are handling. The main reason why our solution stands out is because it's dealing with a very high number of productivity per robot. Like I said earlier, the robots travel much lesser, so they can have a faster cycle time. They're also designed to move at a very high speed, and all of this increases. So we're probably sort of the highest productivity in the market when it comes to sorting robots. We're able to offer double the conventional robot productivity of, on an average, 80 to 100 units per hour. And the other benefit which we are giving to the customers is range and flexibility. So we can have different kind of units like boxes, chutes, bags, any of these, or even a range in terms of low throughput, high throughput, or low exits and high exits. So that's something which allows us to sort of increase our footprint in different requirements of the customers. Very sort of growing internationally now. So basically having solutions in Spain, in Netherlands, in UK very soon, as well as in Atlanta in the US. And sort of happy to have more conversations depending on where your facilities are. Recognized by multiple sort of industry experts or consulting companies or different sort of innovation uh, accelerator programs. I'll skip the details. I'd be happy to walk you through a live demonstration. We have our booth right here behind this at F11. And here's our robot. We'll be able to show you it, show you actual activities being done. Thank you.
Excellent. Thanks for that, Rohit.
Perfect.
Amazing robots. Like the operation absolutely sensational. So I just pose, is there any questions? Anyone? No, that's fine. I'll pose a few questions. So I used to run a 3PL. I actually owned a 3PL business. So
Okay.
I'm very familiar. Obviously, at the end of the day, you'd be walking very tired. Obviously, the robot's kicking in. A massive difference.
Yeah.
Have you looked at it? The fact that you've got, I noticed in the videos, you've got obviously human and robot. Sort of, it's not full automation. It's sort of a, I guess you'd say, hybrid, collaborative
Yes.
Automation.
Yes.
Do you think that's the future? Because we've had a few companies sort of talking about full automation, where you've taken humans completely out of it. You've now got robots, obviously making it more efficient. Do you believe that the future is sort of that hybrid?
Depending on how long the horizon is, yes, I do believe eventually we are looking at fully automated dark facilities where end-to-end processes are automated. But today, or in the next 5 years, definitely we're still looking at the costs being high enough for you to not be able to automate every process possible.
Yeah.
But as we're seeing more and more innovation coming in, the costs are definitely dropping. And that's when I believe we'll probably see a little more darker facilities.
Yeah.
Yeah.
Sure. And just in regards to sort of the, you made mention here about it saves 50 to 70% of the area. Are you seeing these popping up, these type of facilities in central areas of, sort of cities? Or do you think it'll keep being on the outskirts?
So central, when it comes to, let's say, last mile delivery hubs, today, if you notice, none of the last mile facilities have sort of a sorting automation like a cross-belt sorter or any of these sorting automation technologies, mainly because they are space expensive.
Yeah.
So in general, any of these technologies haven't started using vertical space as much as storage or picking automation has. And that's the reason you still see a lot of manual in processes.
Yeah.
So once we start using the vertical space, that's when any automation solution will make some sense. In urban clusters, it could be a last mile facility, it could be a micro fulfillment center. Definitely, it has to first solve the problem of space.
Yeah.
Only then you can probably also get to the second problem of costs.
Yeah.
Yeah.
Yeah, and that sort of leads me to the next question. So ROI, sort of in terms of setting it up, you mentioned, less than 2 weeks.
Yes.
Sort of, this can be set up. Well, that's pretty quick in terms of the setup process. What's the ROI sort of turnaround on this for a company on an estimate, what they would see?
So if you're talking about sort of a capex purchase of the system, we are typically promising less than 12 months of payback.
Yep.
And if customers prefer to use the RAS alternative, where they're basically just leasing these systems, they're already seeing savings of upwards of 66% from the first month itself.
Oh, amazing. Yeah, very good. And just in terms of from a security point of view, obviously with that hybrid sort of system with people walking around. How do these work in collision detection and different things like that?
So multiple redundancies in the system to make sure it's completely safe. One, we have the obstacle detection system, sort of 1D LiDAR today, and we're gradually moving to a 2D LiDAR system where any obstacle, any human, the robots will detect it and pause before it. There is a collision. But essentially, we also have certification requirements require us to basically have fencing around the space. So it's a confined space in which the robots are moving. And any interventions, let's say somebody opens the door, the whole system comes to a pause.
Okay.
Then you can do whatever you need to do and come back out, switch on the system, and sort of runs again. So multiple places where we've sort of worked on even PLD level architecture to make sure that the whole system is extremely safe for human operations.
For sure. And what's the capacity weight on?
So we have multiple variants. This is the largest, and this can handle around 5 kilos.
Yep.
Roughly. And the smaller variant is for the general 80 to 90% of the e-commerce load that can handle around 10 kgs.
Okay.
Yes.
Excellent. Oh, very good. Just have any further questions in regards to it? So you're at booth F11. So
yes.
Everyone drop past and obviously have a look tomorrow.
Yes.
I think everyone will probably be ducking off for drinks now.
Please drop by. I'll be happy to give all of you a demo. And actually, it's always fun to see a robot moving and actually doing its task. So yeah, in a small space, we're happy to give you a demo quickly.
Excellent.
Yes.
Thanks, Rohit.
Thank you. Thanks a lot. Thank you, Nathan.
Thanks, everyone. Thanks.
Thank you.